Okay, so this is the linked model. So this is the structural Revit model. So the house itself here is uneditable within this view. It's only the beams themselves that can be edited. But if we want to get a better view of that, we can actually change how this view is displayed. So over here is a button under the visibility and graphics overrides. So there's two buttons here. One deals with shadows and light and so on, which is just for making the drawing look nice. And the other one is actually line widths and how much weight things are given. So I press this. You can see that at the top here, you can deal with the Revit links in a separate category to everything else that's in the project. So very quickly, I'm just going to go into the Revit links. I'm going to half tone them, which means they're going to be drawn in gray. And then I'm going to underlay them, which means everything in the link is going to be behind everything that's in the file we're working on. If I apply that, suddenly we get something like this. So the structure is completely visible, but the house itself is kind of a ghost image, so you know where you're standing there. Okay, so this is kind of a good way of displaying the structure once you've finished putting it in there. Anything you do in the visibility and graphics overrides only exists within the drawing that you're working on now. So if I go into the first floor level, for example, it's still the same. We can see the beams in here, but it hasn't changed how the floor is displayed. So the 3D view is all we need to worry about in there. Now, what's the best way to do this? Okay, I'll tell you what. I'm going to go into elevation view, and just as let's use the section. Just as we set up a first floor beam level for the top of the beam in the second floor, I'm going to set up a wall plate level. Everybody knows what a wall plate is, don't they? A wall plate. It's just a piece of timber that sits on top of the structural element of the wall that the rafter can sit on top of. Okay, so the idea of it is that because timber expands at the same rate, if you bolt these rafters directly to the wall, they will expand differently to the concrete and it will cause some kind of movement that is not good for anything. But if you put a wall plate in here, it will slide slightly when it expands and contracts according to temperature. So in this case here, you would always put a wall plate on top of the concrete so that the timber can sit on top of that, and you just take a little cut out of it like that. Okay. So I'm going to give a level in there for that. So let's just take a level. I'm going to copy this level up, and I'm just going to give it a more or less where I think it should be, maybe a little bit higher. I'm not going to worry about it too much because we can modify it afterwards. But my idea is that this rafter will be sitting on top of this. We're going to cut the rafter out around it, and then we'll try and do all that stuff in 3D. So we do one there. I'm going to call this one top of wall plate. And similarly down here, I'm going to put another level in here for where I want the beams to be sitting, or the rafters to be sitting. So I'm going to copy this down, and we'll put it. Let's say around about, well, not there. Let's move it again. Just using the arrow keys to slip it down a little bit. Let's put it around about there because we know that we have. I'm just for the sake of this exercise, I'm going to make the structure be in here. Yeah, we'll just do it that way. So I'm going to select this one, and we'll call this one top of window beam or something. Top of window beam. Curtain wall beam. Yeah. Just so I remember what it is. I'll just call it that for the moment. Okay. So now we can go in and we can make a view for each of those. So I'm going to say view, plan views, floor plan. I'm going to make a view for top of wall plate and top of window beam, holding down shift to select them both. Press OK, and they turn up as plans over here on the left. So I'm going to go into top of window beam for. Well, let's have a look at it first. So let's say, because you've got so much glass in here in this in this project. I'm going to assume that this is a steel beam all the way around in here just to hold all this glass, okay? So let's go to the top of window beam. I'm going into structure, and I'm going to go into beam, and let's choose we'll just choose the basic HEB 200. If you want more beam types, you can always load them from your family. So let's press load family, come down to structural framing. There's more beam types in here. You can see there's lots of different shapes of beams and so on. You can put in there. But I'm just going to use the basic one at the moment. So I can either draw it in, or again I can choose on grids. So press on grids. Then Revit asks me at the bottom, select grid lines to place beams along. So I want one to be here and here. And then if I finish that, oh wait a second, that doesn't work that way in this one. I'll tell you what we'll do. Let's just draw it in for this one because it gets too complicated to do the other way. Okay, beam 200. Let's just draw it in from here to here, and we'll do one from here to here, like that. Now you can see the way it automatically cleans up the beams on the end here. You can also play with this. So if I go into 3D view here, there's the beam we put in. You can see it came in at the right level because that's where I wanted to put it. And it's automatically cleaned up with this one being dominant over this one, as in this one goes further and this one retracts. We can also change that. If I select this beam here, a tiny little button up here, this tiny little button called beam column joins. If I select that, we get these little arrows. So I can decide to change, to cut this one back, to put this one forward, or to put them both forward, which then kind of makes a kind of joint, which you can then lock in place. So then you get a beam that's been cut on the diagonal there to put them together, if that's the way you want to do it. So that's the first one. So now we have the lower level beam that's supporting the roof. So then we go into top of wall plate. And for this one, I'm going to insert. I'm going to insert from the family. Let's just have a look at the section first of all, so I know I'm putting it in the right place. Yeah. So we did it on the grid line there. Okay. So top of wall plate. I'm going to go into architecture. I'm going to structure, beam, and this time I'm going to load a family. So I'm going to load down to structural framing, wood, and I'm going to use dimension lumber framing. There's open. Then it gives me a list of standard sizes. Now, you can choose these, or you can actually modify them once you get into the project. So I'm just going to take in a standard one here, assuming it's not in the project already. Yeah, okay, it is in the project already. So let's just go over here and select it. So we go to dimension lumber. And I'm just going to edit the type. So I'm going to edit it, and I want it to be 75 millimeters wide by 45 millimeters high. So let's duplicate it here. And we go 75 x 45, which is kind of a standard wall plate. So breadth is 75, height is 45. Okay. And now again, we can just draw the wall plate in position like that. In 3D view, there it is there. So we've got the two basic levels set up. Okay. Now what we want to do is I want to set up something that deals with this strange join here. Well, I can see that actually this is a weird roof, so maybe we need to be a bit more complicated about that, but let's not worry about that for the moment. What we can also do with the beams is I can decide that this beam here, there has to be a beam on this line here. But how do you draw it so you get the levels correct? You know what I mean? It helps us with this Revit. So if I go into beam, and this time I'm going to choose like a larger beam, the same one we used on the floors. I'm going to choose this one. If I turn on 3D snapping here, I can actually select the line that I want this beam to be on. Now you need to give it an overall Z offset value, Z being the vertical dimension. So you move it down underneath the tiles or whatever you want on top. So let's assume that 60 millimeters is the tile thickness. I'll change it to minus 60. And then if I select this element here, it just draws the beam in there for me. And you can see that it's actually taking it 60 mils down underneath the top of the roof. So there's a couple of things that we can do in there. I'll tell you what I'll do. I'm going to delete that a bit, and then I'm just going to concentrate on this one for the moment, because with this little line here, it just makes it a little bit too complicated for the demonstration. So let's just drag that back a little bit. Put it here. So now, if we want to fill in the rafters between these two elements, what we can do is again use the beam system. I'm going to stop after this and let you try it. Beam system. Instead of drawing the beam system now, I can select the supports. So I can actually select what these rafters are sitting on, okay? So pick supports. So I'm going to select this as a support, and this is a support. And you can see it draws lines on the floor here. And probably this will be a support as well, because if these rafters are coming down, they're going to be hitting this anyway, so we'll use that as well. And then for the end, I'm not going to say this is a support, because the rafters are not going to be sitting on the wall and they're going to be sitting on the beams. So in that case, I'm just going to pick it as a line, like that. So we get that kind of shape at the ground level, which we can trim together, like that. And I'm going to stop after this and then give you a chance to do it. So then beam direction, we can set, at the moment the beam direction is going horizontally. I'm going to change the beam direction to running down this way. And it's very important then that you switch on 3D. If you don't switch on 3D, it's just going to draw these beams on the ground flat. But if you switch on 3D, it should draw them like that. Okay? And then you can play with it later on. We'll get into that, but you can play with the actual joints. Okay, so what I showed you before was to set up a level for the beam, and that's a good way to kind of quality assure the level is correct. But you don't necessarily have to do it that way. If you have a complicated roof, like this is a little bit complicated. So let's let me just finish this first. So what I could do as well is just use the lines here to pick the edges as well. So let's just do that. If I go beam. And I'm going to use the one we made up here. All I need to do is figure out the offset that I want it to be. So if I want it to be underneath the roof, I just said, okay, maybe this one is at minus 200. I can then just pick where I want the beam to be. Reference level. So beam. Pick. I can actually just pick this line and it'll put it in there, and then I can pick this line and it'll draw it up that way, and so forth and so forth. And then I can change it to steel framing and just say, well, I'm going to put it down here, and then I'm going to put another one over here. Now as soon as I get them in there, after I do this, then I can go back and modify them. So if they're more or less correct like this, and let's change the one in the middle there to a larger one, like that. If they're more or less correct, the way I want it to be, I can modify them afterwards. So I can actually fill in all the details first to get all my rafters in place, and then come back and modify the levels afterwards, and everything should follow along. So let's just do that again. So I'm going to make a beam system. This is where it's important that you understand what's supporting the rafters and what's not supporting the rafters. So you have to understand the rafters are being supported off this beam, and they'll also be supported off this beam, because that's the kind of the joint between the two roofs. So I'm going to select that. But they're not supported off the end wall. So then I'm just going to use a line pick tool for that, and then I just trim it all together again. So just make sure everything is trimmed together as a closed loop. It seems like it already was. So then I just have to modify the beam direction. I want it going that direction, not that direction. And we want it to be dimension lumber. Yeah, that's the one we want. Make sure it's set to 3D. It's very important. Accept it. And so it's done it in a simpler way. So then I can quickly do the same thing again on the other side. Structure, beam system, select the supports, this one, this one, this one. Yeah, maybe not that one. Gotta select the line here, gotta select the line here. Trim it together. If you don't trim it together, and if you have any crossing lines like this, it's not going to work. It has to be one closed loop of a sketch. Set to 600 centers. We just need to change the distance or the beam direction so it's going the right way. So it's going that way. Accept it. So now it's done both sides of it, okay? Okay, so if we have something like this as the basis of what we want to do, there's a couple of things that aren't entirely accurate. For example, let's just turn up the quality of that. For example, the wall plate. You wouldn't put a rafter on the corner of a wall plate. That's probably not structurally sound. Ask a carpenter about that. You know, you need to be able to control this kind of stuff. So we can do a couple of things. Like we can take the beams we've put in there, we can modify their position. So we could offset them by either by Z value, Y value. So if I offset this by, let's say, 150, just to see which way it goes, it's coming back into the building again. So you can place this very accurately using this section. The moment it's up here, so it doesn't really comply correctly. That's why I'm saying you should probably place things according to level rather than just picking by lines if you can possibly get away with it on a simple project anyway. So we can also select the beam type, select all instances in project, and we can change how far it extends beyond the other beam to start with. So I can say, I think that's the start extension. I can't remember which way around I did it. So if we change that to 300, just to see what that does. So it shoots the beams beyond it. Okay. So we can kind of do that till we get it to a length that we think is more or less what we want. The next thing we can do is we can use this button up here, which is the cope tool. And that effectively joins beams together with a value. So I say apply coping. Revit asks me in the bottom left hand corner, first pick select element to be coped. So I want to cope this one. And then select column or framing with which to cut. So I select that one. And you can see that it actually makes an opening in it. Now then you can modify this to get the correct height. Modify these beams to get the correct height by giving it a Z offset. Yeah, you can change the coping value as well. So if you select the beam again, over here we have, if I can find it, I always lose this. Joist, end connection, stick symbol, structural materials. And extension. There is a coping value on each beam. There it is there, coping distance. Okay. So you could change that to 10 mils, for example, and apply. Okay. It makes it closer. So it's actually very functional in that kind of way. The last thing we can do is, if we want to cut the beams, now we've got it more or less, it just draws by default these kind of big square beams, but you probably would want to cut it before it sticks out the end of the building, most of the time anyway. So you can actually cut it to any shape you want. So if I just go into a section view, for example, well, that's not the right section view. Let's try an elevation. Okay, here's an elevation view. There's the beams shooting out of the house. I can cut that directly down if I want to, or I can give it a shape to it. So the way to do that is to use a reference plane. And then I'm going to stop talking when I talk about this. And I can either, I can say, well, maybe we want to actually cut it out, something like that. So then I can just select it, press cut, and select the reference plane. Sorry, the other way around. Select it, cut, select element to be cut, which is the beam, and then select the element doing the cutting, which is there. So now it's cut the first beam. So you can actually shape the end of the beams any way you want using as many reference planes as you want, okay? The only thing about it is you have to do it individually. So you have to actually go through and do each one if you want to do that.
Can't you just take that and copy it?
Yeah. No, I mean the thing is, if you're doing a beam system, you can't. What I would do in reality, if I was doing it in a real project, I would make a beam family that had the cut already in it, and then array it. So it's really only for kind of tidying up small corners and stuff like that I would use it in reality. Okay, but I'm not going to tell you how to make beam families this semester. Okay.
Could you just make a
I think my beams are perfect.